talk about bytes and files in Python. So let me bring up my Python window again. All right, and so integers are the simplest kind of object. So let's move this over. All right, and I can probably move that over so it doesn't overlap. Let's see if that works. All right, so here, whoa, didn't listen to me. There we go. All right, so if I set I equal to 1, like I said, Python will figure out what kind of data you're storing, and I'm storing a number, so it's going to be an integer. So you can print the value, and you can print the type of the value, and it'll tell you what it is. So it's 1, and it is class int for integer. So that's not very surprising. And you can set j equal to I plus 1, and it will take the I you defined, add 1 to it, and create a new variable called j, which will also be an integer with a value of 2. So that makes sense. Now, if we try to do stuff with bytes, it's going to start getting a little weird. So if I set a equal to byte b, quote, which is how you make a byte array, I now have a byte array with 1 byte in it, which is 1, \x01. That's the byte of 1. And so if I print that, that is class bytes. If I add 1 to it, I get an error. You can't add an integer to bytes. This is a byte array, and when I use the plus sign, it thinks I'm trying to add it to the end of that, but I can't add an integer to a byte. So that took me a little while to get straight. I thought bytes were equal to characters, but they're not. And I thought bytes might be equal to integers, and they're not. They're separate types of data. All right, so if you want to convert bytes to integers, one way to do it is to pick a particular part of the byte array, and that will turn it back into an integer. So here I set b equal to a of 0. Now when I did this a is a byte array. The b here is not the name of a variable, it's the start of a byte array. So a byte array containing only one element, and that element is the binary value 1. And here I set a new object equal to a, the 0th element, and it interprets that as an integer now. And now I can add 1 to it, and I have a 2. So that's a little screwy, but that's the way it is. And so here is how you would have to add 1. If I wanted to take that array, that byte array with a 1 in it, and change it to a byte array with a 2 in it, one way to do it would be this, kind of going around in a circle. I define it as a byte with a 1 in it. Then I take the first element and call that b, and that's 1 that's an integer. So now I can calculate b plus 1 with c, and now I can use the bytes function to calculate the byte array containing the element c. So now I have created an object, which is a byte array 1 bigger than that byte. So kind of confusing, but you have to get used to this as you move from one character to another, one type of data to another. So let's get out of here and take a look at how you do file input and output. So I made a file called infile. I can cat it. That file just says hello. And I'm going to remove my old out file. I was doing this earlier. All right. So here's how you make, how you read a file. Whoops. I want to be here. Okay. So I'm going to nano file 1. All right. This is one simple way to read a file. You do with. Now here is something I had in loops, and I didn't mention it then. When you have a block of statements that are referred to by something set up by a previous statement, you put in a colon, and after that you have to indent the lines after it. So here I have a condition with that's going to open this input file, reading it in binary. And a series of statements after that are going to be affected by that with. So I have to indent the first one, and now I have to indent every statement by exactly the same amount that is going to be included in the loop. And when the indentation stops, the loop will stop. This also confused me at first because I was used to C, where white space does not matter. In Python, white space matters. It is used for this purpose. So all the next 4 statements are in the block of statements affected by this with. So you open the file. Then if the file is open, you read a byte. Now if the byte is not the empty byte, a byte array with nothing in it, which will happen when you hit the end of the file. Then I have another condition. This one's indented, and another colon means it has another block of statements, so these are indented twice. And these are just for every byte I can read that is not empty, I'm going to print it and then read the next byte. So this will just read a file and print out the contents, whatever it is. And the name of the file is infile. So I can Python 3, file 1. And so it reads the characters one by one and prints them out and interprets them as bytes. So the first 6 are hello, and then there's a carriage return at the end, which it prints out this way, \n, the way it represents a carriage return. All right, now I can make something that will copy one file to another. And that's file 2. So here, I open the in file, put in a colon, then I open the out file and put in a colon. If either one of them won't open, I'll skip to the end and just terminate the program. Then, now, if they both open successfully, I make it to here. Now I read a byte and see if the byte is not empty. And as long as that is true, I stay in here. So I print the byte, I write it to the file named G, which is this out file, and then I read the next byte. So this will take the contents of the file, print it on the screen, and echo it into another file. And the reads from is in file, and the file it writes to is out file. So when I run this, well, first let's make sure I don't already have an out file. So I'll do ls space -l and make my window a little bigger. If I can reach it, there we go. All right, so I have an in file here that's only 6 bytes long, and I don't have any out file at all. So now when I run this, Python 3, file 2, it runs, it prints out these bytes, and if I do ls -l, there is now an out file that's only got 6 characters in it, just like there is an in file that only had 6 characters in it. And if I cat the out file, it contains hello, just like the in file. So that's what it did. So now you know how to read files and how to write files. So there are some challenges here. Here's a file you can download, and count the number of bytes in that file that are 8s. A strange character you don't normally use. Then there's 2 files here. You have to add the bytes together, byte by byte, to construct the flag. And here's another one where you have to add the bytes together, and that will construct an image, and the image you'll have to view. So those are just things that let you practice processing a file byte by byte. All right.